In the last lecture, you learned about stacks. You learned that stacks have the LIFO behavior, last in, first out. We have another very useful data structure called queue, which has the FIFO behavior, first in, first out, and it resembles a queue in the real world. Let's say a queue of people to get into a restaurant. The first person in the queue is the first person who would get in. Now, technically, you can use a list to implement a queue in Python. So let's say we have a queue of 3 items. If we want to remove an item from this queue, we should remove the one at the beginning, as opposed to the one at the end. So we remove 1, and then 2, and then 3. However, if you're dealing with a large list or a large queue, you might see some adverse effect on the performance. Because let's say we have a large number of items in this list. Every time we remove an item from the beginning of this list, all the other items need to be shifted to the left. So if you have a list with 1,001 items, when you remove one item, 1,000 items need to be moved in memory. In situations like that, it's more efficient to use a dequeue object. Let me show you how to do that. So first, we need to import dequeue from the collections module. I'm going to talk about modules later in the course. For now, let's imagine a module is a bucket with a bunch of reusable code. So from collections, that's the name of our module, we should import dequeue, which is a class. Again, I'm going to talk about classes later in the course. So we import a dequeue class here. Now, instead of defining a variable and setting it to an empty list, we should wrap this list with a dequeue object. So we call dequeue and pass our empty list as an argument. This dequeue object has similar methods that we have in the list object. So we can call queue.append. Let's append a few items here, 1, 2, 3. Now to remove an item from the beginning of the queue, we call queue.popLeft. We don't have this method in list objects. So after we remove one item, let's look at our queue. There you go. You can see 1 is removed, and now we only have 2 and 3. Also, similar to lists, we can easily check to see if a queue is empty using the not operator. So if not queue, that means we have an empty queue. Then we can print something like empty. So this is all about queues.